At this very moment, without anyone feeling it, without any vibration, without any sound, the entire universe is expanding. Every galaxy is slowly moving away from every other galaxy. The distances between them are growing, not because galaxies are flying through space, but because space itself is stretching. This process has been happening since the moment the universe was born in the Big Bang, nearly 13.8 billion years ago. For billions of years, this expansion has defined the fate of everything that exists. Galaxies drift apart. Light travels across growing distances. The universe becomes larger, colder, and emptier. But now, imagine something impossible. Imagine that expansion stops. Not gradually, not over millions of years, but that there is a moment when the expansion reaches zero. The universe stops growing. For the first time since its birth, the universe becomes still. The exact moment of stillness. There would be no explosion. There would be no visible boundary marking the moment when expansion ends. From the perspective of an observer inside a galaxy, everything would initially look normal. Stars would continue shining. Planets would continue orbiting. Local gravity would remain unchanged. But far beyond the local group of galaxies, something profound would begin to shift. For billions of years, distant galaxies have been moving away, their light stretched into longer, redder wavelengths. This effect is known as redshift, and it is one of the key pieces of evidence that the universe is expanding. At the moment expansion stops, that redshift would stop increasing. Distant galaxies would no longer appear to drift farther away. The stretching of space would pause. The universe would reach its maximum size. This would be the largest the universe will ever be. The beginning of the fall. Then slowly, the direction of reality would reverse. Space itself would begin to contract. Galaxies that had been moving apart for billions of years would begin moving closer together. At first, the change would be almost impossible to detect. The distances involved are so enormous that even contraction would begin as an extremely slow process. But over millions of years, the effect would become clear. Distant galaxies would stop fading. They would stop drifting away. They would begin returning. Light that once struggled to cross expanding space would now travel across shrinking space. The universe would begin collapsing back toward itself. This is known as the Big Crunch, the opposite of the Big Bang. The sky begins to change. Over hundreds of millions of years, the night sky would slowly grow brighter. Galaxies that were once invisible would begin to reappear. Their light would no longer be stretched into darkness. Instead, it would be compressed into shorter wavelengths, shifting toward blue. This effect is called blue shift. Galaxies would appear brighter, clearer, and closer. The sky would gradually fill with more light. Constellations would change. The familiar structure of the sky would dissolve as distant galaxies became visible to the naked eye. The universe would no longer feel empty. It would begin to feel crowded. The temperature of the universe rises. As the universe contracts, something else begins to change. Temperature. Expansion cools the universe because it spreads energy over larger distances. Contraction does the opposite. It compresses energy into smaller volumes. Over billions of years, the background temperature of the universe would begin to rise. Today, the leftover radiation from the Big Bang, known as the cosmic microwave background, fills all of space at a temperature of about 2.7 degrees above absolute zero. As contraction continues, this temperature would slowly increase. Space itself would grow warmer. This warming would affect everything. Interstellar gas would heat up. Radiation would intensify. The universe would slowly transform from a cold, dark place into a warmer, more energetic environment. The return of cosmic chaos. As galaxies move closer together, gravitational interactions would become more frequent. Galaxies would begin colliding. Stars would pass near each other. Entire galactic structures would be disrupted. The Milky Way itself would eventually collide with neighboring galaxies, including Andromeda Galaxy, forming massive new structures filled with billions of stars. These collisions would not happen instantly. They would unfold over millions of years, but they would become unavoidable. The universe would become more violent. The end of stable space. As contraction accelerates, the distances between stars themselves would begin shrinking. Eventually, even individual star systems would be affected. Gravitational stability would begin to break down. Stars would be pulled into new orbits. Planetary systems would destabilize. Some planets would be ejected into interstellar space. Others would spiral into their stars. The structure of stable systems would collapse. The universe would no longer support long-term stability. Everything would be moving toward everything else. The final era of light. As contraction continues, radiation throughout the universe would intensify dramatically. The cosmic background radiation would become visible as bright light filling the sky. Eventually, it would become brighter than stars. The entire sky would glow. There would be no darkness, only an increasingly bright universe. As energy becomes more concentrated, temperatures would rise to levels not seen since the early universe. Matter itself would begin to change. Atoms would struggle to remain stable. Extreme radiation would dominate everything. The compression of all existence. In the final stage, galaxies would no longer exist as separate objects. Stars would no longer exist as individual systems. Everything would merge into an increasingly dense state. Distances between objects would shrink towards zero. Temperatures would rise to millions, billions, and eventually trillions of degrees. Matter would break apart. Atoms would dissolve. Nuclei would break down. Even fundamental particles might not survive. The universe would begin to resemble the state it was in before the Big Bang, a dense, hot, compressed state containing everything that has ever existed. The final moment. In the final instant, there would be no space left between anything, no distance, no separation. Everything in existence would be compressed into a state of unimaginable density and temperature. Time itself might begin to lose meaning. Physics, as it is currently understood, would no longer be able to describe what happens next. The universe would reach its end, or perhaps its beginning. Because some theories suggest that a collapsing universe could trigger a new Big Bang, a new universe, a new beginning, everything starting again.